Alright, taking a look at practice 2.4.3, comparing linear to exponential functions. So, first one, it says which increases faster, f of x equals 5x or g of x equals 5 to the x. Justify your answer using a graph. Okay. Well, the linear one here, 5 times x, means we're adding 5 repeatedly. G of x, 5 to the x, means we're multiplying by 5 repeatedly, which, if we stop and think about it, is going to become a lot bigger quicker, because timesing by 5 always is bigger. So if we graph them, it looks like this. So we can see here, so f to the x would be the blue line, that's g of x, and then f of x is the red line. And we can see that pretty quickly that exponential is growing a lot quicker. Okay, there's a section where the linear is higher, but the exponential is growing a lot quicker. Okay, number 2. Which increases faster, 2x minus 4 or 2 to the x minus 4? Again, we start at negative 4 on these, okay, roughly. But the idea here is that multiplying is always going to increase faster than adding. Okay, and if we were to make a table of values here of f of x, so we start at negative 4, then every time we're adding 2. Okay, and then for g of x, okay, normally we would start at 1, because it'd be like 1 times 2 to the x, but we're subtracting 4, so it actually started at negative 3. So the way to kind of think of this one, because it's a little different when we shift it, that minus 4 shifts it down. Normally we would have started by 1, and then we would have times everything by 2. Okay, so we'd then have 2, then 4, then 8, and then 16, and so on. But then we're going to have to subtract 4 from all of those, so we go negative 3, then negative 2, then 0, then 4, then 4 would be 12, and 5, which normally would be 32, will now be 28. And we can see pretty quick how much bigger that one's getting. Okay? Alright, number 3, which decreases faster? Okay, 200 times 0.97 to the x, or g of x equals 200 minus 3.6 to the x. Okay, so looking at these ones, we're only going down by about 3%, and this one we're going down by 3.6x. Okay, so typically, again, that multiplication is going to be bigger, but let's take a look at the graph. So on this one, at the beginning, that exponential is decreasing at a faster rate, but as we start to level out, that linear will decrease at a faster rate, only because when you take a percent of something, the smaller the number, the smaller the percent. Okay, so in this case, it would be both of them, depending on which section you're talking about. At first, it would be the exponential, but pretty quick, that linear would outpace it. Okay, and so number 4, kind of the same idea, which decreases faster, 1,000 times 0.85, or 100 minus 0.15x. Okay, again, that exponential, because we are decreasing, kind of like that last one we just showed, it's going to eventually have a very small decrease. So at the beginning, it's going to be exponential, but over time, that linear will end up decreasing faster. Okay, and we could try to take a look at it if we wanted to. So we start with f of x here. So we started at 1,000, and now we're timesing by 0.85, so that becomes 850, then 722.5, then 614.125, then 522 for 43.7. Okay, and then we would just keep going. But it's still, going down pretty quickly, whereas subtracting 0.15 is going to be really small. So it's going to take a long time before that linear actually starts to, because we're subtracting 0.15. So I'd say for the most part, the exponential is still going to be decreasing faster until we get to a very, very, very large number for x. Okay? All right, number 5. At what point does the value of f of x exceed the value of g of x? Okay, if f of x is 2 times 8 to the x divided by 4, and g of x equals 8x plus 4. Okay, so now we're trying to find where one gets bigger than the other. Okay, and a graph is a really great idea for this. So let's see our graph. By the way, all these graphs I've been showing you guys I've made on Desmos. Great graphing tool, desmos.com. You can also download the app of the same name. So, f of x is the red, so we can see clearly right here that at about an x value of negative 0.284, they intersect, the linear and the exponential. Okay, so, but that's in the negative, so that really doesn't make sense to exceed. Okay, so f of x, as we go, right here at this point, 6.3 for x, that's when f of x is bigger than g of x. So, at what point? It's 6.375, comma 55.002. Okay, and really graphically is the best way to figure that one out. Okay, I mean, you could make a table, you could try to solve them together, but that's your best option. 6. At what point does the graph value of f of x exceed the value of g of x if, again, exponential and linear? Okay, again, I'm going to go straight to the graph. Okay, so f of x, our exponentials right here. Okay, we've got some pretty big numbers, and it's got its curvature. Okay, and this point right here, so the linear is bigger until we hit this point of 9.828, 63.931, and then the exponential is bigger. All right, so now let's look at number 7 to 10. You are looking to invest $450. One savings option follows the function right here. F of x equals 450 plus 450 times 0.055x, where f of x is the amount of money in savings after x years. The second option is represented by the function g of x equals 450 times 1 plus 0.04 divided by 12 over 12x, where g of x is the amount of money after x years. So again, we've got a linear here, and we've got an exponential right there. Okay, so which one's going to increase faster? It's always going to be that exponential, okay, because we're multiplying. Multiplying always outdoes adding, okay, but let's take a look at a graph again. So if we look at this, g of x, okay, f of x, so they start off both at 450, right? Okay, and at first it looks like the linear one wins out, but here at 15.26, okay, that's when they're the same, and that's when the exponential gets bigger. Okay, so at what point does the value of g of x exceed? So this one at first, but overall that one. So that point is 15.26, comma 827.685. Okay, that's the point where g of x exceeds. Alright, and it says, move this up here. If you were looking to invest your money for fewer than 10 years, which option would you choose? Okay, well, fewer than 10 years, okay, since that 15 stands in for 15 years, if it's 10 years or, 15 years or less, basically, you want to go with the linear one, okay, with f of x, because you are getting more money right out at the beginning. But if you're going past the 15 years, then definitely g of x is the one, because now your exponential is going to make you more money, okay? So even though that linear at the first little bit makes more money, over time that exponential will do a lot better. Okay? Alright guys, there we go.